Hello friends, today we are going to learn about IP version 6. As you know, IP version 4 have, was being used up till now, and although it is still being used, but the IP version 4 address space is soon going to exhaust, and the people who are managing this address space realize that IP version 4 addresses will not be sufficient for the foreseeable future. So they started developing a new protocol, which was IP version 6, which will have or contain much more IPv6 addresses or IP addresses than they are in IP version 4. So in this lesson, we are going to understand what is the difference between IP version 4 and IP version 6. The main difference is that IP version 6 address space is bigger than IP version 4, and IP version 6 addresses are written in a different notation than IP version 4. So let's begin step by step. First of all, as you know, IP version 4 address was 32 bits in size, while IP version 6 address is 128 bits. Right. You are seeing in numbers or binary numbers or bits. So we see that the enhancement is from 32 bits to 128 bits. But if we convert this to decimal, the number of addresses that we are going to have in IP version 6 is much more than IP version 4. As you know, in binary, with each increasing bit, the number of values we get doubles. For example, say if we have 2 bits, then the number of values we are going to get is 2 raised to 2, which is 4. If we increase the address space to one more, that is 3 bits, then the number of values or addresses we are going to get is 2 raised to 3, which is 8. Right. So the numbers doubles with each bit. Similarly, if we have say 4 bits address, then the number of addresses we are going to get is 2 raised to 4, which is 16. Then which again doubles then 3 bits address space. Similarly, if you look at IP version 4 and IP version 6, IP version 4 address is 32 bits. If it was increased to 33 bits, it would contain 2 into 2 raised to 32 bits. That is, the number of addresses that we get in IP version 4 is 2 raised to 32. And as soon as we increase the bit from 32 to 33, the number of addresses that we will get in IP version 6 will be double of IP version 4, right? But the IP version 6 address space is not increased to 33 bits, it is increased to 128 bits, right? So it is difficult to even imagine how much IP version 6 addresses will we get in IP version 6, right? All I can say is that this is much bigger than IP version 4. Second thing, if we talk about the notation that we use to write a IP version 6 address, how it is different from IP version 4. As you know, IP version 4 addresses are written in dotted decimal notation. Right, like as you know, IP version 4 address is 32 bits in size, but when we write these 32 bits, we write them in decimal and these 32 bits are divided into 4 octets, like first octet separate, then dot, second octet, third octet, then fourth octet. First, second, third, and fourth. Each octet contains 8 bits, right? And the IP address is written in decimal, like 192.168.1.10, like this. But in IP version 6, the address is larger than IP version 4, and it is written in hexadecimal, right? So a sample IP version 6 address will be like this, say 2340 colon. The separator used in IP version 6 is colon, and it's not dot. So 2340, say 1, 2, 3, 4, 5, 6, 7, 8, 0, 0, 0, 1, say double A10 colon double B20 colon double C30. It could be anything, any hexadecimal character. Then say 1111, like this. Right. So this is a sample IPv6 address, and it is written in hexadecimal. So there are in total 32 hexadecimal characters which are there in an IPv6 address. Second, these 32 hexadecimal characters are divided into 8 quartets. IP version 4 address has octets, and each octet contain 8 bits. In hexadecimal, there are in total 8 quartets, and each quartet contains 4 hexadecimal characters. So, like we are seeing here, 2340. There are 4 hexadecimal characters, and it's known, or it is called a quartet. So there are in total 8 quartets like this. First quartet, second, third, fourth, fifth, sixth, seventh, and then eighth. And as you know, each hexadecimal or one hexadecimal character or number is equal to 4 bits. So since in each quartet there are 4 hexadecimal numbers, so it will turn to each one quartet is equal to 4 hexadecimal numbers, which in turn translates to 16 bits, because each hexadecimal number is equal to 4 bits, so 4 hexadecimal numbers will be equal to 16 bits, right? So as you can see, a IP version 6 address is very large, and it will be very difficult to remember this address, as well as it will be difficult to configure this address on each PC manually. So there are various mechanisms in IP version 6 wherein the address configuration is mostly automatic. We will discuss that also. But before that, let's learn how we can write IPv6 addresses in a short form, if it is possible to write in short form, right? So we are going to learn how to abbreviate IPv6 address or addresses. For this, let's suppose we have an IPv6 address which is say 2340. colon 0000 colon 0000 colon 0001 colon 0000 colon 0000 colon 0000 colon 0560. Right. So this is our sample IPv6 address. Okay. And let's see how we can write this address in short form, or how can we abbreviate this IPv6 address. First of all, you know that leading zeros are meaningless, right? Like in decimal, if you write a number, or if you have a number 0009, this can be written as simply 9, because the leading zeros have no values, right? But if you have 9000, this cannot be abbreviated. This should be written as 9000, because the trailing zeros have values attached to them, right? So first thing is that you can remove the leading zeros, right? So as in decimal, same thing applies to the hexadecimal also. Here you can remove the leading zeros, right? So in the second quartet, as you can see, there are 4 zeros. So you can remove these 3 leading zeros in the second quartet. Similarly, you can remove these 3 leading zeros in the fourth quartet, 3 leading zeros. Similarly, 3, 3, 3, and in the last quartet, this single zero, which is a leading zero, this can be removed. So this IPv6 address can be written as 2340 colon 0 colon 0 colon 1 colon 0 colon 0 colon 0 and then colon 560. Right. So this is the uh, first method of abbreviating an IPv6 address. You can remove the leading zeros. Second thing, if we, in your IPv6 address, you see that there are multiple quartets of all zeros. Like we are saying here that the second and third quartet are of all zeros. We have abbreviated it here. You can see in the full address that the second quartet and the third quartet were all zeros, and then the fifth, sixth, and seventh, these 3 quartets were also of all zeros, right? So while abbreviating an IPv6 address, what we can do is we can remove uh, those quartets which are all of zeros, and replace them with a double colon, right? But we can do this only for one such occurrence in an IPv6 address, right? So this IPv6 address now can be abbreviated in one of these two forms. First is, if we replace these two contiguous or continuous quartets of all zeros with double colon, this address will become 2340 double colon, right? These two quartets were reduced to or replaced with double colon. Then the rest of the address 1 colon 0 colon 0 colon 0 colon 560, right? But if we replace these three continuous zero quartets, then this address will become 2340 colon 0 colon 0 colon 1. Then these 3 quartets of all zeros will be replaced with double colon. We will always use double colon, right? It is not the case that if we have say 3 quarters, then we will place 3 colons. This is not it. It does not matter whether there are 2 quartets of zeros or 3 quartets of zeros. We will always use a double colon, right? So we replace these 3 quartets with double colon, and then the rest of the address 560, right? So this address can be reduced in any of these two forms. This one is also correct, this one is also correct, right? So if your IPv6 address contains quartets or continuous quartets of all zeros, you can replace them with double colon, but you can do that for only one such occurrence in an IPv6 address, right? Why is that? If you see the first reduced IPv6 address is the first one. If we look at it, there are first quartet, second, third, fourth, fifth, sixth. We can see that here six quartets are written and then there is a double colon, which means that if there are six quartets written and there is a double colon, it means that this double colon means that there are two quartets of all zeros. So this address can be expanded, right? Similarly, in the second form or second abbreviated IPv6 address, we can see that here there are first, second, third, fourth, and fifth. There are in total five quartets written, and there is a double colon, which means if there are in total 8 quartets in an IPv6 address and 5 are written, then this double colon means there are 3 quartets of all zeros which can be expanded, right? And as I said, that we can replace those continuous zeros quartets with double colon for only one such occurrence in an IPv6 address. Why is that? Say if we reduce both the continuous quartets, it will become 2340 double colon 1 double colon 560. Here we have reduced 2 and here we have reduced 3, but that is what we know. If we look at this address, it will be impossible to decipher where. So let's look at it again. Here we see that here this is the first quartet, second quartet, and third quartet, right? So three quartets are written. That means there are five quartets which are of all zeros. But it will be difficult or impossible to tell whether these five quartets of all zeros are divided like two quartets here, three quartets here, or three here and two here, right? Because both are possible. So this is a wrong abbreviation. We cannot abbreviate like this. There will be no two colons or double colons in an IPv6 address, right? So this is how we abbreviate an IPv6 address. You can remove the leading zeros and then you can replace continuous quartets of all zeros with a double colon, but only once in an IPv6 address. Second is, in IPv6 address there is no concept of subnet mask. What we have here is like in CIDR notation, the network portion is known as prefix and the host portion is known as interface ID, and the number of network bits are known as prefix length, right? So say if we have an IPv6 address which is a host address, say 2340 colon 1 colon 1 colon 1, then say colon 2 colon 3 colon 4 colon 1111/64. This is how an IPv6 address is written. Right. The /64 here indicates that this IPv6 address has 64 bits in network portion. Right. And as we have already discussed that in IPv6 each quartet is equal to 16 bits. That means these first four quartets are in network portion and the last four quartets are in host portion, right? So if we want to know the prefix or the network address on which this host resides, then how will we calculate, right? As in IP version 4, if we need to calculate the network address, so network address is derived by turning host portion bits to 0. So if we turn all the host bits to 0, this address will become 2340 colon 1 colon 1 colon 1, then 0 0 0 0 slash 64. And if we abbreviate this address, it will become 2340 colon 1 colon 1 colon 1. And since here there are four continuous uh, subnets of all zeros, this can be replaced with a double colon, and it will become slash 64 like this.